To one all watching this video. I am Vinay Dilip Lunkar. By education, I have done my BE in chemical engineering. I have done my PGDBA in HR, and my 10th grade or 12th grade education has been from the Central Board of Secondary Education. As a child, my favorite subject was unusual, what is not everyone's favorite subject, which was namely social science. For me, the motivation to be a teacher, unlike for the overwhelming majority of youngsters who in recent years or as of now might be approaching the teaching profession, for me it was my passion. In the sense, it was the only thing I ever wanted to do. No other profession ever entered my mind. No other thing, whether it be joining the industry or otherwise, nothing attracted me the way teaching did. I don't know what it was, but it was something that inspired me, something that enthused me. Back on the 10th of Feb 2016, when I did join it, and as I learned along with this profession, I was thrust into a role which had both the admin side of it, which also had the teaching side of it. I realized after 6 months, after 1 year into this profession, that this is one of the rarest of rare professions that, especially if you love it, you get paid for doing what you love, and also you earn the respect of the society. Those parents or students with whom I could help in or contribute in getting a good result, the kind of respect and the kind of raw admiration they give is possibly unseen or unheard of in any other profession. Coming to what I am going to show here is, I would like to touch upon a small 10 CBSE concept of the chapter Chemical Reactions and Equations. I just want to deliberate on the 4 basic types of reactions as far as chemical reactions and equations is concerned. The first is a combination reaction. In simple words, a combination reaction is anything where 2 reactants or even more than 2 reactants can combine to give one single product. Reactants being on the left hand side, the product being on the right hand side. So, if any reactant A plus B or even more reactants combine to give you, say, a product C, it is combination. Reactants can be 2, they can be more than 2, but they will combine to give you one single product. That is combination, as the name suggests. The reactants combine to give you one single product. So, suppose our A is C, suppose our B is O2, C plus O2 giving CO2, where our C is CO2. 2 reactants reacting to give you one single product. That is combination for you. Decomposition is the second type of reaction. It is literally and metaphorically the reverse of combination. One single reactant splits to give you multiple products. One single reactant splits to give you multiple products. And in this reaction, on its own, no reactant is ever going to split into multiple products, but the reactant, when exposed to heat conditions, temperature conditions, pressure conditions, sunlight, or catalysts which speed up the rate of the reaction. When in different cases, when the reactant is exposed to any of these, or in some cases, multiple factors of the ones I mentioned, to give you 2 or more products, that is decomposition for you. One single reactant splitting when exposed to a catalyst, sunlight, heat, pressure, temperature, etc. to give you 2 or more products. Example being, say, calcium carbonate upon heating gives you CaO plus CO2. In this, C can represent calcium carbonate, A can represent calcium oxide, and B can represent carbon dioxide. The third reaction I would like to talk about is the displacement reaction. The displacement reaction, simply put, A plus BC giving you AC plus B. A displaces C, or A displaces B from C and itself combines with C. The only thing is this reactant A, which is going to displace B from BC and itself become a part of a compound along with C. A has to be more reactive than B. And how do we know whether A is more reactive, whether B is more reactive? By a phenomenon termed as reactivity series. So, if you have, say, Zn plus H2SO4, where A is symbolizing Z and B is symbolizing H2, C is symbolizing SO4, ZnAC will combine to give you ZnSO4 plus B, which is H2. Zinc could displace hydrogen from hydrogen sulfate or sulfuric acid only and only because zinc is more reactive than hydrogen as per the reactivity series. And last but not least, I would like to speak about double displacement reaction. The general form being AD plus CD giving you AD plus BC. AD plus CD giving you AD plus BC. So, basically, positive and negative ion compounds, positive and negative ion compounds. The positive ion of the first combines with the negative ion of the second. The negative ion of the positive ion of the second combines with the negative ion of the first. It's an exchange of ions. It's an exchange of individual elements which might be the part of the overall compound. AgCl plus NaNO3, where A is Ag, B is Cl, C is Na and D is NO3, can give me AgNO3, the positive ionic part of AgCl and the negative ionic part of NaNO3, and NaCl. So, once again, in summary, I have 4 kinds of basic reactions to talk about in this video. The first is combination, where 2 reactants or more reactants combine to give you one single product, A plus B giving you C. Decomposition, where one reactant splits to give you 2 multiple products or more than 2 multiple products on exposure to heat, sunlight, temperature, pressure, catalyst, you name it. C giving you A plus B. An example being CaCO3 upon heating giving me CaO plus CO2, where CaCO3 is calcium carbonate, also known as limestone or chalk or marble, CaO being calcium oxide, CO2 being carbon dioxide. Displacement Zn plus H2SO4 giving you ZnSO4 plus H2. The general reaction being A plus BC giving you AC plus B. The one important factor to decide whether displacement can happen or not, A has to be more reactive than the reactant C, which is part of BC on the reactant side. Double displacement AB plus CD, complete exchange of ions giving you AD plus BC. A simple example being AgCl plus NaNO3 giving you AgNO3 plus NaCl. That's it for this video. Thank you so much.